Now, there's a way to solve using matrices. So what is a matrix? A matrix is an array of two terms. An array, a square array of terms that are used in an area called linear algebra. I'm going to give you this command in Maxima just to show you that a 2x2 matrix can be referred with the letter A, and then the sub-indices refer to the row and column. That's first row, first column, first row, second column, second row, first column, second row, second column. This is a 2x2 matrix, and we're going to use this because we've been dealing with two equations only. There's a quantity called the determinant. For a 2x2 matrix, the determinant can be calculated in Maxima like this. And what it is the product of the diagonal terms, A11 times A22, minus the off-diagonal terms, A12 times A21. That's how simple as you calculate the determinant of a matrix. Maxima has a function called determinant that allows you to calculate that for any numbers. If we want to create the matrix of coefficients of a system of equations, what we want to do is go into the matrix menu and say enter matrix, right? And so we're going to enter a 2x2 matrix. Basically what we're going to do is we're going to take the coefficients in here as the row and columns. And it says give it a name. Okay, we're going to name it M for matrix, general type. And we're going to say OK. Then you get this entry with the shape of the matrix where we're going to enter the values 5, -8, -6, 4. And what I'm getting here, I was actually enter a text here, but basically what I did, I just repeated this entry, right? So if you don't want to go through the whole process, you can just type M matrix parentheses and then a list with the top row 5, -8, comma, and a list with -6, 4, close the parentheses, and you get this matrix. The determinant of this matrix will be the 5 times 4 minus 8 times -6. Or you can do it by just typing determinant M. Okay. Now we have terms to the right hand side -23, 17. That's sort of a column vector. Okay. We can extract the column vector using the insert matrix. The values are -23 and 17. So we could go like I did here, like. I'm going to do it right here. It's a matrix, enter matrix. This matrix has 2 rows but only 1 column. And we're going to call this B for the vector on the right hand side. And the values are -23 and the second value is 17. Say OK. And that's what we get, that matrix B. So we're just repeating the command right here. I'm going to delete it to make it less clear. So we have these two. One matrix and one vector. Now we're going to calculate the determinant of matrix M, and we're going to call it D. Now we're going to form a matrix where we are going to replace the first column with the elements of the vector B in matrix M. So we're going to put matrix -23, -8, 17, 4. And calculate the determinant of that matrix as dx. We're going to do the same thing, but replacing the second column, so with -23 and 17, the values of the right-hand side vector, and call that determinant my. It turns out that the solutions for x and y that I call x sol, y sol, are equal to the determinant dx, the one when we replace the first column with the vector on the right-hand side, divided by the determinant of the matrix of coefficients. And for y, in a similar manner, the determinant of the matrix where we have replaced the right hand side with the elements in the right hand side of the equations, and divided by the determinant of the matrix T. and we get the results as minus 11, 7, 53, 28. We're going to check these using redefining the functions, the equations, and then making x equal to y sol, x equal x sol, y equal y sol, and substituting those solutions into equation 1 and equation 2, and we get equalities.